So when you're looking at the ideal gas law, if you recall, it's Pivner, and so we have pressure, volumes, moles, and then our R value. This R value changes based on what the pressure is. Most of the ones that we're going to be doing today are going to be in atmospheres for the pressure, and so we're going to use that 0.08206 value that's on the back of your formula sheet. If you were to do any of these, and for example, they use torr, which is TORR, which is the same thing as millimeters of mercury. If you look on the back of your sheet, the R value becomes like 62.36. So do be careful with that. And here, I think most of the ones you're going to do today are the 0.8206. But if you see anything with like millimeters of mercury or TORR, you have to use that 62.36. So be careful there. So what I like to do when I'm working out these problems is I just kind of pick through the words like I always do, kind of go scavenger hunting, and I kind of go ahead and in the reading as I go through, I label each variable, and then because you are dealing with 5 variables, I do like to write my formula and rearrange it before I put numbers in for this. All right, so let's kind of look through this. An 8.5-liter tank, and so I'm looking at this, and that's my volume. So I'm kind of gonna go ahead and just label the stuff. Contains, maybe I don't circle it because y'all are used to circling the things that are the answer. So there's my volume, 8.5-liter tank, contains helium gas at 16.9 atm, so that's pressure. Okay, so I'm kind of like in my mind sort of filling in, what I'm going to put in this formula here. And then as soon as I see Celsius, I know I can't do that, okay? So I'm going to go ahead and add the 273 for Kelvin. So that gives me 298 degrees Kelvin, and so there's my temperature, how many moles, and so I'm solving for moles, which is N, right, are available for making balloons. If you write all these numbers down, and then you start moving it around to rearrange it, you don't have to rewrite a lot. So it's easier for these because you have so many variables to write the formula, so write out your Pivner, and then I know that I'm solving for moles, and so I'm solving for this guy. And so to get a variable by itself, we have to look at what's being done to it. R is being multiplied by, N is being multiplied by R and T. So if this was math class, and I wanted to solve for N, would I not have to divide both sides by RT? So this is math class. I don't know if you figured that out yet. It's cleverly disguised as a science course, but it is math class. And so now I have N equals PV divided by RT. And so now I'm just going to fill in my formula. Again, R, because I'm dealing with atmospheres, is 0.08206, and it has a lot of units. So for this class, I wouldn't worry about writing them right now. I think we're okay. So anyway, oops, I think I did that down. I did. Sorry. It's pressure, right? So pressure goes on top. Oops, I didn't mean to confuse you. So pressure is 16.9. I apologize. I'm just filling that in. Y'all okay? I didn't mean to mess up. Pressure and then volume, I have it labeled. So see how nice and easy it is to just read what I wrote earlier. So just making stuff up off the top of my head. And then I see R is on the bottom. Okay. And so 0.08206. Yeah. And then it has, liters times this and that, blah, blah. So on your formula sheet, I'm going to write the whole thing. And then the temperature is 298 degrees Kelvin. And so to solve for moles, like honestly, all I have to do now is just plug it in my calculator. Doesn't it sound great? I like this game. And we spent a lot of time going into what all these variables mean and talking about each one. So it's nice just to be able to do the math a little bit. Make sure you use parentheses when you're doing the bottom of it. If you take it all together. And I'm looking at my stuff that I was given, and my values I was given. The one with the fewest, it has 2 sig figs, and so I'm going to make this 2 sig figs, so 5.9 moles, and then it's, what is it, helium? Let me know if you have any trouble with this, or if that's not what you get. How are we doing? You can't tell me that this is not just like math lesson. It's just class.
So unless you go in that, it becomes
Yeah, and if you want to see how it becomes moles, I obviously don't have that formula sheet in front of me, but like the units for this has moles and liters and degrees Kelvin, and so the units for it are, I believe it is, give me a second, it's like the units I think are like, I'm probably going to screw this up, but it's ATM times liters over moles times Kelvin, I think, is it? Well, I know, but I'm showing you how I can do it without having it in front of me. Like, I don't have that right here. And so, like, if you go to canceling, see, ATMs cancels, liters cancel, and you're left with one, or moles on the bottom of this fraction. And so, when you solve everything out, because you're dividing by 1 over moles, you're really multiplying by moles. And this is, I'll catch you next year on this. Do you know what I mean? It's not worth it. For this class, you know you're solving for moles. There's 4 variables you stick in, so it's not a big deal. So, but they do cancel, and that's a great, when they kind of get more complicated, that's a great check point to make sure that you didn't mess up. But for this class, I don't think, it's not worth it. It's not worth writing all that out to me for this simple of a problem, because they get much worse. But that's, if you want to write it out, you certainly can. And so here you can see how Kelvin cancels, liters cancel, ATM cancels, and you're left with moles. All right, so the second example problem, they trying to throw something in kind of weird here. So let's not freak out though. So all the helium is used. So that's that. All the helium. Guess what helium that is? Like that's the helium we just saw for. What is all the helium? What was that number? Yeah. So this is okay. 5.9 moles. So that's N, right? So all the helium, so that's one of my variables. Anybody sad there? Cry? You see how I did that? That's not a magic trick, is it? Alright. It's used to fill 1.5 liter red balloons. This is volume, looks like volume to me. Let's keep reading the problem. It's not as clear as it seems. At 0.99 atm, so this is pressure. And 32 degrees Celsius. So when I see this, I'm just going to go ahead and fix it. So 273 plus 32 equals, is that 305 degrees Kelvin. Now, notice it doesn't say, you know, it's like, what do they want? How many balloons will you end up with? And so what I need to do here is I need to kind of write out my formula, and if you look, I have moles, so I have P. The V part is a 1.5 liter balloons, but you know, do I know how many balloons or anything? No. And so basically, what this question is saying, hey, if you have all these little red balloons that are 1.5 liters, excuse me, I think this will make my point. Plus, I blow up balloons for fun now. Really kidding, but so if I have a bunch of these balloons that hold 1.5 liters, how many balloons can I fill up? This is a volume problem, and when I get a volume, let's just say I get, you know, if I got 4.5 liters overall, like that would be 3 balloons. 1.5 plus 1.5 is 3, plus 1.5 is 4.5. Okay, so basically I'm going to have to solve for volume and then divide to figure out how many balloons. All right, so we're really solving for volume, and then we'll be able to divide. If that's kind of tricky for you, that's okay. We're really just using Pivnert right now, and that's kind of fun. So Pivnert, and I'm going to write it, and then I'm going to rearrange it. I'm going to solve for volume, so I'm going to get my variable isolated. Then I'm going to do that by dividing both sides by P. How do you feel about that? This problem for anybody. Why don't you go ahead and see if you can solve for that total volume all by yourself. And then I'll help you out with the balloon part. I'm going to quietly be working this out up here. done yet, so I'm not worried about my sig figs yet because I'm not done. Okay. So my overall volume is 149 liters, and I have balloons that will hold 1.5 liters. So what mathematical operation do I need to do now? Yeah. So I'm going to take that number and I'm going to divide by 1.5, and then I will know how many balloons. And so, you guys, mental math time. Do you see how this is almost 150? Turns out that 1.5 times 100 is 150, so should be around 100 balloons. You know, see, 1, 2 decimal places in the same number. That's mental math for you. If you're not there, that's okay. Every time I do that, hopefully it gets better. 2 sig figs, so I get 99 balloons. The practice problems we'll do in a minute won't have like crazy balloon stuff, but that wasn't the worst thing. We're just practicing problem solving skills. This is just good problem solving. So what I'm going to do is I'm going to skip over to practice or 2 types of work, and I'm going to go straight to the ones where you have to like go from moles to grams and stuff, like I had asked you about on the new now. Is everybody okay with this? Don't you wish I had been doing this all year? That'd be all right, wouldn't it? Yeah. Sorry. 99 balloons. So we're going to come back to this where you solve for the molar mass and the density of a gas. So this is the next question. What volume, okay, so I can already tell, volume is what I'm searching for, can be produced when 68 grams, and that is methanol. 68 grams of methanol burns in air at 25 degrees Celsius and 102 atms. So do you see how this grams of methanol, that's this guy, and it's asking me about CO2. Can you guys go, can I put a mass in this formula? No. So I'm going to need to take, and it's burning in air, so am I going to run out of oxygen? No, it's air, so I'm good. So I'm going to need to take this grams, and I'm going to go to moles, and then I can go to moles of CO2. See? And so I need to solve for moles of CO2, so we're going to just do a quick stoichiometry problem. And so that'll give you my N. I'm going to have to do a little problem to fix that, but that'll give me my N. 25 degrees Celsius is 298 degrees Kelvin. You can just take my word for it. That's room temperature right there. Just happen to know that. And then this right here, you know, is my pressure. So I have temperature, I have pressure, I'm looking for volume, and then I have what I need for N, but I just have to do a quick conversion. Can you guys go from grams of methanol to moles of CO2 real quick? Can you do that? You should be able to do that. I'll do it here quietly, but you do it on your paper. So go to your palm first, go to moles, and then go to your other palm for the other moles. Rounded a slight bit on my my molar mass, but I'm not sad about it. And I'm not done yet, so I'm okay with writing all these numbers down. So again, let's kind of take inventory of what we have. We did solve for the moles of CO2, so we have N. We have T, it's 298. We have P, it's 102. R is going to be the 0.08206 because I'm doing ATMs, and so I'm solving for volume. So we need to rewrite the formula, and I'm just going to do this down here. So I'm solving for volume, hit NERC. Take the time to do this, it's worth your time. Solving for volume. So I'm going to divide both sides by P. So volume equals nRT divided by P. And now we can just fill in what we know. Volume is equal to 2.125 moles of CO2. And R is 0.08206. Temperature is 298 degrees Kelvin. And then the pressure is 1.02 atms. And, I can only have 2 sig figs, so it ends up being 51 is volumes in liters. That's okay? So, there's 2 other kinds of problems where you can actually solve for the molar mass of a gas based on some variables, and you can actually take the density of the gas and solve for stuff. Those are a little bit harder. If you're not super good at math, they are very confusing. But they're fun if you like math. So you can either, does anybody want to hear how to do those? You'll get it next year. Okay, good. You'll get it next year. We'll spend, like, what I'm about to show you is kind of like, it's not the hardest kind of gas stuff, but it'll be difficult for your friends, probably. Anyway, I'll show a couple of y'all that. But what you can do now is if you don't want to hear that and you're feeling good about some pivot art, you just want to plug stuff in. Okay, that sounds good. You're going to get a book just because I feel like these questions at the end of this, they're good questions, but they're just add stuff in your class. Like some of y'all will be stressing about it. It's not a big deal. So there's a book page right there, 468 and 469. I just wanted you to do 67 through 77 odd, and they're really straightforward. And I went ahead and wrote the answers, on the board up there. So you can do that. Or you can listen. So you can listen to me. That's 5 questions. And so if you don't want to do that, you can just do 5 of these questions. But let me show you how to do that stuff first. So if you want to hear the other ways and other stuff, you just come up here. And if you don't want to, get a book and get busy. Okay, deal?
So we're doing the 5 questions instead of this.
Yeah, those are not fun. Yay, math. So if you want to hear all this stuff, come here. Is everybody where they want to be? Okay, so the thing about molar mass, if you think about the molar mass of carbon dioxide, like the definition of molar mass is grams per mole. So on these molar mass questions, what y'all are going to have to do, they'll give you a gram amount of the gas. You're going to solve for the mole amount of the gas, and then you're going to be like, grams per mole is the molar mass. It's really straightforward. So let me kind of talk you through this. An unknown gas is collected, and so you can already see how they're throwing stuff in. Like 850 milliliters. So that's 0.50 liters. So I'm already like looking at this going, no. Okay, so that I do have a volume here. Okay, and for these more complex ones, like I actually like, and this is what I'll teach y'all next year, I like to just be like I do this, and I'll show you to do that next year, and just keep a list. And so, because in terms of temp, it's not like 5 things and you fill it in. So the volume I know is 0.850 liters. And as I keep reading the problem, it might be that something else comes up. So you just have to keep track of it. And I have 1.02 atms and 23 degrees Celsius, and you do have to always show that math. So you can kind of see I'm filling this in. It's nice, right? The evacuated vessel has a mass of 138.5, and the vessel and the gas have a combined mass of 144.2. Let me ask you a question. Does it matter how much the vessel it's in weighs? Am I pivot out a bucket or something? No. So, well, okay, first before we do N, what's the value of R going to be? Yeah, all that stuff, right? Okay. then it has units, and those are good to have. So this N right here, if they don't give you moles, you'll have a mass to work with, okay? It says it's an unknown gas though, so I can't do a whole lot as far as going to moles. But what I can do is, it wants me to find the molar mass, which means that when I'm done, I need a gram answer divided by a mole answer. Can I take all of this information and go ahead and solve for moles? Do I have enough information?
No.
Do I have enough information to solve for moles?
Yeah.
Because I have 4 out of 5, don't I? But like, I'm gonna need the grams. Can I find that up here?
140 plus 12 minus
Yeah.
130.
Piece of cake, right? So I think that ends up being like 1.7 or something. I mean, I don't know. Let's get a calculator. I didn't do this in the first period. Nobody was interested. So it ends up being 1.67 grams. So listen, for this, all I have to do is I'm going to do all this formula. I'm going to get moles, and the definition of molar mass is grams per mole. So I'm going to take that grams, I'm going to divide it by the moles, and I'm going to be done. That's very nice, right? So on your paper, go ahead and do Pivner. And so we're solving for moles. We don't know N. We still don't know N, and I always kind of get myself a little mark. But if I rearrange the formula for N equals PV over RT, I believe. Yeah. Okay. Did I do that right?
Yeah.
Sorry. Sometimes I do stuff and I'm like, is that right? So pressure, so 1.02. And I'm gonna leave my units out just because I'm gonna run a room. No, I can fit it. Never mind. I'm just kidding. Units are our friends.
Excuse me, Miss Freeman.
Yes, ma'am.
Do we have McDonald's to check out?
Yes, ma'am.
Thank you.
You're welcome. So solve for N, and then you're gonna put that answer right here, and then you're gonna take the 1.67 grams and divide it by N, and that will give you your molar mass. Isn't this fun? Like a puzzle, huh? See you next year. Is that super fun? Hey. The density one's a little bit suckier. The molar mass ones are okay. You don't have to find moles. You don't have to find grams or moles, one of those. They won't give you the molar mass. You have to like investigate it. Well, no, they wouldn't give you molar mass because you're solving molar mass. But it's kind of like you're going to have everything else except for N, and then you're going to have to go. Okay. So, anyway, there's that hot mess. And then I got 46.8. Did y'all get that? Yeah. All right. I didn't go through this morning. So there's their moles. Yep, good. I didn't do it this morning, so I was hoping it would be okay. So the density of it. An unknown gaseous hydrocarbon has a density of 3.24 grams per liters. Find its molar mass. And so, like, go with me, okay? You have Pivner, okay? N, this N right here. And I might need to just like show you the steps. But in moles, and this is on the formula sheet, this is on the yellow formula sheet, moles is equal to mass divided by molar mass. And that's just I think it's, let me see where it is. I'm pretty sure it's on the back. It is. Yeah, so it says, I believe you Oh, N equals mass divided, capital M is molar mass, and there you see two capital M's. So to find N, mass divided by molar mass. And so what's density, y'all? Grams per liter. Like that's because the mass will be in grams here. And I know it should be like centimeters cubed, but for volume for the ideal gas law, volume is going to be in liters. So grams per liter. And so I can just take this grams, put it right here, and put liters right there. Do you want me to like, this is, I can do it myself better. Jesus. See you next year. Alright, so let me show you what I'm trying to do. So Fibner, okay, and so they're giving you, if I take N, I can replace N with mass divided by molar mass, right? And they use MM, same thing. And then I still have R and T. And I think they had rearranged it even more than that. I don't remember which one they had. Oh, they went ahead and divided this side by volume. See how I can divide that side by volume? Because move it from here, move it from here. And so anyway, this mass divided by volume is density. So I can fill my density into there. And then you'll be able to solve for pressure in this case. And you can rearrange it for whatever you need to do. But that's what you have to do. This one's kind of crazy. You just want to have to play around with this a little bit. Let me pull up a practice problem and kind of do it with you. Do you see that like ninja work there? That's some ninja stuff. Let me do the problem. How about that? He said, yeah, let's just do the problem. I need all this crap to go away. Can I borrow one of y'all's paper so I can go to a black?
The next slide
Is blank? Okay, perfect. That looks crazy. Okay, good. So, I don't like that they went ahead and rearranged it. Let me start from the beginning and we'll derive the formula. Things I don't normally say. So PV equals nRT. I know that N can be replaced with mass divided by molar mass, RT. And that equals PV. I know I need volume on the bottom because mass divided by volume is density. So I'm going to divide both sides by V. And that leaves me with P equals mRT mV. This stuff is a joke. And I'm solving for molar mass. That's this capital M right here. Mathematically, I can just switch these, but I'm going to multiply both sides by M. And then I'm going to divide both sides by P. So you end up with molar mass equals M, and then RT VP. I know I lost you there. Been illusion? You just rearrange the formula. And so now what I'm going to do is, this M is the molar mass, that's what I'm solving for. So now I can start filling some stuff in. This is what they have, and this symbol is for density, okay? So molar mass is equal to the grams per mole, that's mass, that's grams, 3.24 grams. R is 0.0826. I'm going to erase this because I ran out of room. And y'all are going to have to play around with this when I get done talking. Like, you're just going to have to embrace the stuff and move stuff around. That's okay. 206, yeah, it sure is. And it's really 0.0821, like in my head, so that's why I keep screwing it up. There. The temperature was up there. It was, we had already done it. So it'd be 301. We didn't do it already, did we?
Sure.
It is 301 though. We did 20.
Yeah.
It's 301. And then the volume was 1 liter, because it's 3.24 grams in 1 liter. So 1 liter, and then the pressure is given to me. Nope, just kidding. Pressure is 1 atm. So your answer should be around like 7, I think. I haven't done this, I'm just doing mental math. could be totally wrong, but I feel like that's about right. Like I said, nobody in first period was filling it.
We got 80 plus that.
Did you?
They're close to.
Oh. This is, can I tell you how I was thinking about it? I was thinking about it like a tenth of, like 10% of 300, oh, it's 30, not 3. It's 30 times 3. So that's how I did it. I was close. Shh, shh, shh. I was feeling real good about it. You know, as I get older, I get better at that mental math stuff, because when you're in school, like, they just beat it out of you. Brilliant. Okay, so that's the idea. Okay, so you can pick any 5 questions on that sheet, any 5 you want, and do them. The density. Is it say molar mass? Oh yes, if it's molar mass, it is transferable. Thank you. Perfect. Awesome. So the molar, when you're solving for the molar mass, those are easier than the density ones, but the density ones are kind of fun. But you just have to like arrange that formula. You have to fill in the mass divided by molar mass for N, and then you have to fill in the density for the grams or the mass over the volume. It's just like a little tricky thing. So I mean, it's fine. Like it's either this or you plug 4 things into holes with 5 things, and then push on your buttons. I mean, so it's your choice. But if you think next year you'll ever just get to plug things in and push buttons, you're completely wrong.